Hey, welcome everyone. Anybody wants to go first on what they were able to get done on this competition last week?
Hi guys. I've just continued on with what I had before. So yeah, whatever the top sort of public notebook is, I just took that and expanded it a bit by like adding in revealed targets, as I've said to you before, and yeah, like it seems to go okay. At the
Did
minute, I'm
the
still just.
did the change in the API kind of screw you up, or did you have to add that,
Oh
whatever
no,
we
that screwed me up for quite a while. Yeah, I couldn't figure out what was going on. I hadn't realized the API had changed. Did they? I hadn't been reading the discussions for a while, so I hadn't noticed. And then yeah, I couldn't figure out why. Yeah, my training in the loop stopped. Yeah, I also trained a model in the loop as well, and yeah, that all broke because they added some new parameter into the test set.
Yeah,
Did they
actually,
not?
they seem to have this flag which, and they're doing something really weird. They have data which they are currently which they could be testing us on, but they are not testing us on that, which is kind of, at least for me, it's lame because it's like, hey, at least if you already have the data, then you know, give us the feedback on how our model is doing on that. But anyway, I had, my submissions kept failing, as probably yours did as well, until I went to a couple of notebooks or discussions that pointed to, oh, you need to add this conditional flag or whatever.
Yeah, so I had those problems. Yeah, like during the week, so like there was that. Yeah, because like I take the test, whatever the test data frame they give you, like in the loop, and like I combine that with the revealed targets. And yeah, suddenly I was getting an extra column in it, and I hadn't realized because then I used that to build up more training data during the API loop, and then like I
Do
train
you,
more.
so when you do that, Steve, do you retrain the entire model at every new step, or do you do it at some periodicity?
No, I just do it at intervals. So I do it every 10 days of their data. So every 10 days is what, 55 samples per day.
Times
So
200 times 10.
yeah, so 55 times 10. Oh yeah, something like that. Every 10 days or whatever. But yeah, so like
Okay.
yeah, so like that's one thing that's worrying me because of the fact that when it actually goes into the private leaderboard stage, yeah, like it's going to be what, 3 months, and so there's going to be extra data. So each time I train a model, obviously it takes a bit of time. So
Right.
yeah, like if extra training data comes along, then my notebook's going to slow down. So I need to make sure I leave enough time to train models if I go with this approach.
Right. Now, the other thing I had a question on is when you do that, um, do you just use that model, or do you combine that model with the current trained model and use an ensemble?
I combine it. Yeah, so like I have, yeah, like as I say, like the public notebook at the minute, that one with the purged k-fold thing, yeah, like it
Right.
gives you sort of about the best score. So like it gives
Right.
you 6 models, is it? So I
Yeah.
import them, and like that's like the base, and then every 10 days of the test API, I train a new model and I add it to that set. So yeah, like as the thing goes on, it's inferring with extra models every time. So the number of
Hmm.
models is
Right.
building up as it goes.
And do you drop the, you don't, you already have it in your model, so you don't care about dropping the early part of the data. You still use
Um,
that as well.
well, I have a limit on how much data because like obviously if I just took more and more and more data, it'll get slower and slower to train the models.
Right.
So yeah, at the minute I only take like the last whatever 66 100,000, something like that.
Oh, okay. So some number of days that you limit starting at the end and going backwards.
That's right, yeah.
For your new models.
Yes.
Yeah, so finally I figured out, by the way, what this whole or combinatorial purge CV stuff, and it's thanks to actually there's a fascinating series of time series oriented. See whether I I'll also eventually post this. Oh, when you guys can my screen yet?
Yep.
Okay. So this Conrad, going to scroll this name, he has this whole series of posts and talks on the Abhishek's channel, and this I find, and this particular book is actually the 10th in his 11 step thing on series. So this is where, you know, this notebook kind of goes through, what I really like is it goes through every single one of the various methods, like random, k-fold, what's walk forward, what's group time series, for purge group k-fold, and then combinatorial purge group k-fold. And he has uses the same. In fact, interestingly, he kind of takes the ubiquitous data set, which we were talking about, and applies the splits. This random split and what random split does and why that's not. And he applies that to a screen and validation, and shows how much of a difference there is between the validation score and the test score. You can see there's a large gap. And then, you know, k-fold, what does k-fold do and why k-fold doesn't work when it comes to time series data, because you're using kind of future data, which means that you're leaking. But it's still better than just random k-fold. You can see this little bit of a gap narrowing, but then he goes on to walk forward, which is interestingly, I think, kind of what the guy, even though the guy in the 5-fold CV notebook that Steve and I are using as a base, he kind of talks about PPCV or combinatorial purge, but he doesn't do that. He actually kind of leaks data in the way he does it. But this is the strict walk forward, and you can see in the walk forward that key thing is, you know, the size of the training set keeps increasing, but the test set size remains the same. That's kind of the way I remember it.
Yeah.
This question?
Yeah, Srinivas, yeah, absolutely. Like, yeah, k-fold doesn't make sense, but does he do like, for each talk we have multiple time points, right? So just keep stratify on stock. Right.
No, actually, in this case, as I'll get to in a minute, because there is the grouped k-fold, and the grouped k-fold is grouping is what do you group on? And in this case, that kind of goes away, or I should say that, you know, the concept goes away of grouped k-fold as applied to this problem if you group on dates, as Steve and I and the guy who's doing the 5-fold does. because then all the stocks of that day, because eventually you are going to have to predict for all 200 stocks on a particular day. That's what you are expected to predict. Right? So in this case,
you predict one at a time, right? Or no? You don't. Your model doesn't predict all 200. I'm sorry, I'm just catching up. So
it's for the it predicts that all of the 200 for each of the 55 time steps. That's what you're expecting. Or in other words, now let me take that back in the following sense, right? Like it's normalized with respect to the weighted average target. So you take into account all of the 200 stocks.
okay.
Right. So
yeah,
so you could split on each of the 200, but it kind of goes against the target that you're being set up here to predict, because the target prediction is of, the way the target as compared to a weighted average.
Okay.
So you factor in all 200 stocks in your prediction, is what I'm trying to say. If you look at what you're predicting, you have to take into account all 200 stocks for any particular day, which is the reason that you don't, in this case, group on stock basis, but grouping on the day basis is what makes for this competition.
Yeah,
it's basically really, like time series split. I mean, right?
Yeah, but splitting on the day is like seems really. Maybe I just
you don't want to see you don't want to leak, right? So you don't want to see future. So you have to split on day itself in this case, right? Like the figure that Srinivas is showing, if you look at the x-axis, which was on the top, it's time. So
yeah, but there is some, even if you split on the day, there is some correlation, right, between this, like, because it's the same stock.
But you are trying to use that correlation to make the prediction, right? Like splitting on stock, I mean, you would have to build like 200 different models in that sense.
Yeah.
And also, as I was saying, the target that you're predicting is factoring all 200 stocks. So if you split on the stock, besides the time problem of what Prickle said, you also have this eventual post-processing problem of having to combine each of the stock predictions into a 200 weighted average prediction that you then use.
Okay. Yes.
So this is the forward. Then he gets into kind of, in the walk forward, the training set keeps increasing it as one version of it. The other version of it is to do this, which is, you train on one, predict on two, train on second, predict on three. And in fact, this version is interestingly what the CPCV guy does. And actually screws it up a little more, because for the fifth thing, he just takes the 480th time step as the only validation. So I don't know why he does that, but that's what he does. But this is one other way to do the walk forward, right? So limiting the set of the training set. And in fact, actually, I think he discusses it, or at least mentions it in the video. There's a way by which, when you use the time series split in sklearn, then you can do either one of these things by using a variable which limits the training set, size of the training set. If the size of the training set is none, then it'll kind of increase it this way for time series validation if you use that. And if you specify you can specify the size of the time series training step, and if that's the case, then it will do this, because it limits the training set to one fold. So you train on this, predict on the next, train on this, predict on the next, and so on. So these two variants of time series split exist. Now, So that's what he's showing here in the time series splits. Then he shows that that gets a little better with respect to your prediction.
Sorry, Srinivas, is there a clear winner between those two? Whether you're limiting or spending more data for the time series split? Or are they pretty similar?
Yeah, they're pretty similar, but
okay.
What I found when I was playing around with our current data set, is that increasing the training set does have an effect.
Does, okay.
But I didn't, because I hadn't gone through this notebook, because this lays it out much clearly. I was kind of a little bit confused, so I didn't quite do what he does here. Well, actually, I did do what he does here, but I quite didn't do what he does
limiting
here.
Okay.
Right. So it wasn't an apples to apples comparison, is what I'm saying. It wasn't exactly these two alternatives, but it was somewhat close to it. And what I found was, as I increased the training set, my model got better. And again, keep in mind that he doesn't in this case use the one other, and by the way, this one other addition that the fivefold guy does, which I think is smart, and I posted the ChatGPT explanation of what it does on the Slack. He uses the fivefolds to find the best number of iterations and the single, kind of the depth of the tree, and then uses that to create another fold and trains it on the entire data. And that's something which I think is a smart thing to do, because you're not, you gain two benefits from it. One is you gain the knowledge of the folds to determine the depth, and then additionally, you're not missing any data because you're training that last model on the entire data set rather than on any particular fold. Right. So that's an additional twist that the guy who implemented fivefold CB did, but then he, as you and I discussed, he did screw up the leakage stuff. So this is time series. And then the grouped time series, and then he talks about, the pros and cons. And this histories of filtration comment is important to keep in mind, because that will come into play when we look at why or what is the difference in combinatorial purged CD. So that's kind of, you can go through the pros and cons. And then the cons, as you can see, is there's one single scenario is tested, right? Which is that you always think of the path with the future being after the past. So that's why it's also called walk forward in either of these scenarios, whether you increase the training set or you keep the training set fixed. In either case, fixing the past and then predicting the future, right? Now, the next thing he talks about is the group time series. And the group time series, this is where I was confused initially when I was going through this notebook as to how the grouping concept applies. And later I realized that in this particular computation, as long as you are splitting on a day, it's, the group, you are grouping by day, so it kind of automatically falls out. So there isn't necessarily an additional thing you have to do here for the group k-fold, but in other instances of time series where you might have to create groups, then the grouping becomes important. Right? So in our case, it may not, as long as you split on day boundaries, the grouping is natural in the sense that the days are the groups. So that's the group k-fold, and the nice thing is he provides kind of the indices to say, to show you what happens in a group. And I think this is another insight that if you carry, then it makes it clear group k-fold is just a combination of time series split with a group k-fold applied on top of it. So you, right, and it was, in fact, I don't think it still exists in scikit-learn. I may be wrong, but it's, somebody who wrote the group time series split code, and so he just kind of incorporates the code from a Meetup implementation, Kaggle. I think, yes, in fact, this Gara guy is, I think, the guy who implemented the group time series split. So this is not time series split, but group time series split. So he split based on the group. And in our case, it doesn't really matter as long as you split on the day. And then that performs even better than before. The gap between the training and the validation set narrows even more, is what he shows. And then the purge group time series, so step by step, so it's the kind of group time series, then the purge group time series, and the reason he explains for it is kind of interesting. The purging, and I didn't get this either, and at least until even by reading the book, I wasn't sure why the purging. I mean, theoretically I understood, but the explanation the guy gives here seems to be at least one valid explanation. And the way he says the purging, what it accomplishes is, sometimes you have in a financial situation where the transaction occurs on a particular date and the closure date is something nearby, but not yet the same date as the date when the transaction occurs. And if that's the case, and the closing of the transaction happens at a different date, then you don't want to use the data between the transaction date and the closing date. And that's what the purging is used for, at least as he explains it. And that makes sense to me, right? Because the closure date when the transaction actually closed, I mean, recently I bought something and I realized that, for some strange reason, there's a 5-day gap or a 3-day gap between when I bought something and when it showed up in my account. And actually the cost or the price is the date on which it closes, not the date of or vice versa. The closure date has an impact on the transaction, which is the reason that that window between the transaction date and the closed date, or whatever they call it, is the purging duration that the guy applies. But at least that's what he explains. The purging is explained slightly differently, or different reason in the, not different reason, but the way it's explained in the book is to just say effect on the label. But that's a kind of theoretical concept. But this explanation that the guy gives in the video resonates with me better as to what the purge window is expected to be doing. Okay, so the purging, and if you kind of apply the window on the back side of a test, by that I mean if a test fold is followed by a train fold, then if you apply a gap between the test fold and the next train fold, then that's called an embargo. Whereas the gap between a train fold and a test fold is called a purge. So there's a purge between a train and a test. There's an embargo between a test and a fallen train. So this is just, and here he doesn't show embargo, but
sorry, Shreyas, what was the difference between the embargo and this?
So here you see, right, that the purging is happening between the train and the test.
Right.
Right. Now, when we go to the purge combinatorial stuff, you'll see that in this case, that scenario doesn't occur because the train is always followed by a test. But when you go to the combinatorial purge, you can have the situation where there's a train following a test.
Right.
So
okay.
Think of it as the train, another train on this side of this orange block, on the right side of the orange block. Right? If that's the case, the gap between the test and the start of the train is an embargo.
I see. Okay, cool. Yeah.
Got it?
Thanks. Yep.
Yeah, so that's an embargo, whereas this is a purge.
Okay.
So you can see that other than the gap between the train and the test, this is very similar to, the grouped time series or the time series for that matter. And so this is the purge group time series split. And so group time series is the basis, and then we add a gap. Right? We can specify the size, the training gap, and the validation set, and then that makes it even better. But now comes the final method, if you will, which is what the guy claims to be implementing, but he doesn't, as I keep repeating. But combinatorial purged. So here's the key thing about it, and this kind of finally tied it all together, at least for me, because I was terribly confused by any other explanation of this CPCV thing. So assume that you have 5 folds, just like we are implementing in the group 5-fold, or when we split on dates that Steve and I are using. So in the 5 folds, if you use 1 fold for validation, then you just have 5 combinations, because it's 5 choose 1, you just have 5 options, right? So that's what we saw either in the time series choices, which is you use 1 fold to train and another to test. Now the size of the train fold can vary, but basically that's what you do, and you ensure that the fold is always in the future of the train. But once you purge an embargo, you can think of and if you choose multiple folds as your validation, so if you say 5 choose 2, if 5 choose 2, I think is 10, right? So you have 10 different combinations of 5 choose 2. So by that, I mean you use any 2 folds out of the 5 as validation and 3 folds as train. Okay. And now as long as you purge an embargo, you can use any of these combinations of folds and validate on the 2 folds you have chosen as the validation folds. That is what leads you to 10 potential backtest paths, right? So that is the diagram like this, right? And here, of course, he doesn't show it as, think of this as the 2 folds and these as your training folds. Now, for some reason, he doesn't show the exact sizes, but you can, I think he illustrates with 6 choose 2, which is 15. In our case, it's 5 choose 2, which is 10. Right? But basically, the choice is you split it in 5 folds, and then make sure you have the purging and the embargoing between the folds, and then choose any 3 folds to train and 2 folds to validate. That's what CPCV technically and precisely implemented should. And by the way, I did implement it for a 5 choose 2 stuff. And you see on my submissions, I have the 10-fold series, but I had to bundle with it for quite a while until I got it to work. But all my stupidity. But 10-fold CV, it kind of, I trust this particular model a lot more than others, but it gives me a little worse score than the 339 I get with the 5-fold CV, where there is actually leakage of data. I mean, here I'm just calling it 1, 2, 3, 4 because I give it a random state, as Steve talked about in an earlier discussion. But this is the precise implementation of the 10-fold CV. I call it 10-fold because remember that there are 10, it's actually 5-fold, but there are 10 parts because I'm doing the 5 choose 2 in each case, right? And 5 choose 2 is, if you do the combinations, it's 10. So you have 10 different parts that you're validating. In each instance, you're using 3 folds and validating on 2. Now, the thing that somewhat and this is something worth discussing, is in this particular CPCV method, you do use data from the future to predict the past. Because some of your parts would be your two validation folds could be in the past, and you are using training data from the future. But you're purged and embargoed to ensure that you've limited the impact of, any leakage. But in a macro sense, you could argue that there is still leakage in the sense that, for example, if the market is at a much different point in the future than in the past, then you are bringing that knowledge into this particular way of doing the prediction. But I don't know that that is necessarily leakage or not, or at least I could argue both ways. I don't know what any of you guys think about that. But at least finally I understand what CPCV is and what to do to implement it. Of course, I hard-coded the cutoffs, and I haven't switched to, because that was simple when I didn't understand it. But I still have to go back and use the code that he provides. I think there is code. There is some other thing. I haven't switched to using this. Actually, you were going to ask?
Yeah, I was just going to say that explanation makes a lot more sense now, so thanks. It's kind of, the mind-blowing part, I don't know, is because of, I think we've been kind of tuned to say that don't look at stuff in the future. That's why,
right.
I see what you're saying about arguing both ways. One question I have in that figure that you were showing right now, there is the dark red part is the embargo/purge, right?
Right. Yes.
So how do you go about choosing that? Do they need to be the same? Any insight on that?
Yeah, a good question. I just used what the guy in the 540 actually uses, a purge of 2 and a gap of 5 at the end of the training. So the embargo becomes 7. That's why I was saying I was thinking you could switch.
Okay, that's what you're saying, hard-coded versus, okay.
Yeah, so I just kind of had, I split it, given 480, I just hard-coded the numbers and then coded the equations to get for each fold. That is, if it's less than this and greater than this, but those numbers, this and that I'm calling, were hard-coded. Whereas until, you can do it, see here, you can do 6 choose 2. So I would just say 5 choose 2, and then you can give a purge of 1 or 2 and a % embargo.
Okay.
So that would be a %. I have to figure out what it's a % of. I'm assuming it's a % of the whole, but it could be a % of the whole too. I have to figure out which.
So,
but then you can do it this way.
Okay. And and is this correct that purge and % embargo in our case should actually translate to like X number of days, right?
Yes.
It's your, okay.
Correct. Yeah. So that's why I said that it was for the guy who implemented the notebook used 2, then a gap of 5 and a 2 embargo, which effectively meant, an embargo of 7, right? Because if there is a gap between a train and a test of 5, and then you again do an embargo of 2, that's like providing a gap of 7 between the ending of one train and the start of the next fold.
Oh, I see what you're saying. Oh, I thought purge was always like if it was train and test.
Yes, but the additional, but the way the guy in the 5.4 implemented, if you look at the code, it's purge, then a gap, then embargo. And he adds the gap at the end of train. So that's why it effectively becomes an embargo of 7 days.
Okay. I need to see that. Okay.
But this took me a whole lot of digging through this, and then, because I was terribly confused about CPCV I was like, okay, if there's one thing I get from this competition, it's going to be I need to figure out what's going on there.
Yeah, this notebook seems very, very informative. So thanks for kind of walking through this.
So I'll post the Slack. I'll post the thing on Slack, and if you really are into time series, then this whole series thing, because actually I watched the video the guy went through, and he does a really good job of taking you through, and there are some Q&As he answers as he goes through it. It's an excellent notebook. So given that, I believe this whole series, if you're interested in time series, would probably be very worthwhile to go through.
Yeah,
and all of them
this guy seems to know his stuff, because I have a notebook that I'll share which talks about, like, I was mainly looking at parameter tuning, but yeah, I'll get into that once you finish.
Okay, so this is what I was up to, and hard coded. I haven't yet transferred over to utilizing this, but as you see, my score with this tenfold, what I call it tenfold, but fivefold to two validation is slightly worse. But I think I would probably now I can start focusing, I guess, on trying, although it's going to be harder, what Steve is doing of incorporating some of the new data and trying to model with that.
Oh, how far is your public score versus the score that you're seeing?
Quite close.
Quite nice. Okay.
Yeah, so the whole point of this is that this isn't going to improve your model at all. This is just giving you a better idea of how your scores are.
Mm-hmm.
So so like the 53442, what cross-validation score did you get with this system? Did you get close to 53442?
53442. Yep.
Yeah, no, but what did your cross-validation show?
Cross-validation, let's look at it. It actually depends on the folds, right? So some of the folds are fairly high. They show 6s.
Well, yeah, like in the original notebook, so it gives you like an average score. Yeah, so like the whole point of this is so as you can compare your at the bottom of that, I think there's
so
an
if
average
you look
of them
deeper
all,
and you see some of them improving, but you can see a constant 6 stuff, right?
Yes, so they're the average. Yeah, 6.24.
Okay.
Yeah, I've noticed in all of these public notebooks, like all this cross-validation stuff, nobody ever puts it through. Like when you're actually doing your submission, you stick it through that zero-sum thing, the function immediately below.
Mm-hmm. I was going to ask about that.
Yeah, like nobody ever puts their cross-validation through that. So I was wondering if you stick your cross-validation.
Oh, yeah. Right, okay.
Okay, so I spent a little bit of time on the go-to, so let me jump to that for a minute, because I was like stuck at what is this go-to thing, or what is the zero-sum thing doing, right? Because there is this zero-sum function, which is what the go-to conversion. So basically, as I understood it, and thanks for raising the point that they don't put the CV through that. I didn't notice that, Steve, so I'll dig into that a little bit more next week. But the important thing, what the this go-to conversion is what is happening when they implement this too rapidly. But this go-to conversion is where the zero-sum matters. Because what they're trying to do apparently is adjust for something called, something called a long shot bias. And the long shot bias, as I understand it, is, I'll explain it more in the simple way that somebody else explained it, which is to say that apparently more people bet on long shot in horse racing because they believe that if they win, they would win bigger money, which is true. But because of that, the odds of the good odd horses or the horses which have better odds are adversely impacted. And this zero-sum thing is one way to fix that bias, is what I understood, but that's still a surface explanation. And I just bookmarked these couple of books and the GitHub implementation of the go-to conversion, which apparently does a better conversion of betting odds to probabilities, which is the reason that the zero-sum thing is used. So that at least it should point to what that function does. Now, Steve has raised the fascinating question, and I'll have to dig into it to see why people don't put it, the CV through that. But I'll post the link to these couple of notebooks where I was digging into why the zero sum and what the heck does the zero sum thing do. Hopefully that at least some pointers, although I haven't dug into that as much detail and gotten to the bottom of it. What I do know are the zero sum helps to calculate or translate the odds into probabilities in a less biased way than any other way, and it accounts for this long-short bias, which other ways of translating odds to probabilities apparently does not. But then, Steve has a very good question of why.
Yeah, like I was just wondering, if you stuck it through that, then the cross-validation score you get, will it be more closely aligned to what you get on the public leaderboard score?
Interesting. Ought to try it. Very good. Steve, that seems like a good thing to try. But as you say, I mean, this is not an improvement of the model, so which is why I was saying I just wanted to kind of get this methodology understood and then move on to what you've already been doing.
Yeah, sure. Like, yeah, like having this, you're getting a much better estimation of how good your model is. So it's like, yeah, I haven't really sort of paid much attention to the CV score, which in the past has come back to bite me or whatever when when you drop down the table. So yeah, it's good that you're doing that.
Yeah, I think opens up this whole sleuth of experimentation now if we can kind of nail this.
Yeah, because this is following on Raquel's thing that the CV is always the most important thing, right? I mean, like you say, retainers also, it kind of is what's the best, and I haven't done that. But this time I just was like fixated on understanding the CPCV because it just confused me so much. I was like, I'm totally lost. What are we doing here? And then spent enough time to where now at least I know what it is. And that notebook really helped, and the video associated with it. I would encourage people to watch that.
Yeah, thanks for that explanation. That was helpful.
And by the way, the parts, the one last comment I would make is, you remember the parts from the, the parts which were connecting the red arrows in one of our earlier discussions, which kind of went through. So apparently what I put together, and this is, speculation and or intuition plus guess from what the book says, but doesn't explicitly say, but what I saw somewhere else, but as well is the parts that go through. So now when you have 10, you still have 10 choices of combinations, right? Or 10 combinations of why choose 2, but only certain combinations take you through a path which will enable you to calculate in a financial case the P&L, for example, because there is a succession of the way you have chosen the 2 tests to validation, so that it moves down the time series. So you can add the profit and loss at the end of each of the through the paths. So that's the reason that the paths matter, because we completely ignored the paths in this discussion so far, right? Because I just focused on the combination, but there was this other concept of the paths that was talked about in the CPCV, and I was like, what the heck are the paths and why do they matter, right? So the paths matter because the paths are of those 10 combinations, the paths give you the combination where you can add the profit and loss because the timing sequence is appropriate.
And by any chance, do you know, like, so why or what is the criteria? Or I'm just wondering, like, because
the criteria is the sequencing. If you look at the, I'll stop sharing. Anybody have easy access to? I have to pull up a whole bunch of. Give me a few minutes. You can
Stack
talk
Overflow
about
link?
something else, and or at least the picture of that path. Somebody can pull that up, then I can talk.
It's there on our Slack. Let me see if I can pull it up. Give me 1 second.
Is this the link that you,
Yeah, mine post the link. Yeah, that's the link. Just pull that up. Pull that up. Okay, let's see whether you guys can see it now. We know when you can see it.
Yeah, we can see it.
Okay, so you see these parts. These are the parts, right? The green. So what you see in the parts, remember that the vertical is the time. So this is where you can add, because of the flow of the test choices are such that each test is that each of the, you're still choosing two. You're choosing this and you're choosing these two, but this sequence that you go through, right? This one, then this one, then this one, that allows you to keep the tests in time sequence. Therefore, you can do the P&L at the end of this, to the P&L at the end of this, to the P&L at the end of this, as I understand it, because it's flowing in time in sequence. So if you're kind of like making so much profit here, then you can combine that profit to this profit here, to this profit here, or the loss, as the case may be. That's why this, again, if you see this, the test groups flow in time sequence. You see the second part? This test follows this test follows this test follows this, because this is the time sequence.
Okay. I'm curious why, like, is this a valid path, like 1,2, and then 1,3, and then 2,4? Or basically the whole first row, like the 1,1, 1,2, 1,3, test.
No, because this is not time. This is time. This is why this, remember, even when you asked, I was terribly confused, but this is time. So these are just the various combinations.
Folds.
So
Okay.
this is not, these are just combinations of fold. This is just the fact that you're using the third and the fourth fold as the training set, and the first and the second fold. I don't know, there may be one more in the picture, but you see what I mean, right? Like this is not time. And in fact, you had asked earlier, like, and I was very terribly confused. That's why. So the only time in this is the vertical axis. These are just choices or combinations. That's why this technique is called combinatorially purged cross-validation. Because then in a financial context, you can add the P&L, if you will, at the end of this and this, which means at the end of this, and then the second combination, and then the third combination. So that will tell you the profit and loss of this method using this. Any other way, you can't do it. So the only way you can do it is to use the paths.
Okay. So in this example, it's 4 choose 2, right? So that is like 3 paths. Correct?
Yeah. And again, if you look at exactly, yes, 4 choose 2 is it 3? Yeah, 3 paths. And then here is a sketch for a more complicated 5 choose 2. And again, if you look at the 5 choose 2, you will always, and so it leads to 4 parts. And again, in the paths, you'll always find the test in time sequence. And that's the only explanation
so I'm wondering,
that I have found that satisfies me.
Okay. Now, so in your case, where you've done 5 choose 2, which leads to like those 10 folds, right? And you were seeing varying CVs across them, the individual folds. So is there something you need to choose from those 10 that probably better represent a match to whatever your actual CV should be? Does my question make sense, or is this just profit and loss, so it's not relevant to us?
Not, I, at least as I think of it, not relevant to our particular competition, but that I just wanted to mention, since we are so close to understanding the whole thing, as to why the paths matter, or the paths added to it, because we don't use the paths in our case. But because, we are not doing a profit, but that's and I was still puzzled even at the end of all this. And then I saw somewhere in the, maybe even in the video accompanying this explanation or somewhere, that P&L is mentioned. And that's when it, the light bulb went off in my head that, that's why these paths matter, because you can use the path to kind of combine at the end of each. You can't do that for any other combination. So if you're trying to evaluate a stock trading approach, for example, this is what you would do, right? You need to know what is your P&L at the end. That's something that we are not bothered with in our current, because we're just predicting the values. But if you were to add this additional, I want to maximize the values, then what you're saying will become important of choosing the paths.
Okay, makes sense.
Okay, so that's kind of what I spent most of my time on figuring out.
Awesome. And are you using, I'm just curious, like with this, I'm not sure which notebook you're using, but are you using like just the base 17 or 18 features, or have you done more feature engineering?
No more than what that guy has done. And in fact, I did try one thing which was suggested. I'd like to hear whether Steve tried anymore, but one thing I tried was somebody mentioned that the day of the week may not be a good thing to incorporate. So I tried removing it, and at least for the particular instance I tried it in, the score went down. I haven't tried it with all the variations of the CV and stuff like that, and see whether, because somebody in one of the discussions said that may not be a good, if you go back to notebook. And yeah, there is a day of the week. So, but ignore. Look at. And by the way, this is what I meant. Like I did it I equals 0, and I hard coded the dates. And by the way, this is what I meant by saying gap. Yeah, here you see this. Somebody said if you could, remove it, you might get a better result. I did try it in one of my variations of notebook, but actually score went down. Steve, did you try any more?
No, I've just got these features that this guy has. Yeah, so I've got those three time things: the day of the week, the seconds, and the minute. Yeah, I just figured if it wasn't any use, the model would ignore it.
Yeah.
But yeah, I hadn't been on the discussion, so I hadn't seen. But yeah, certainly my best models have that in it.
Yeah. Hey, I'll post a link to this go-to discussion and this notebook that talks about these variations of validation approach. Is there any good discussion, Steve, other than what you already said in prior meetings about how to best implement this lag stuff?
What, adding the feature lags into the data?
Yeah, adding the newer dates into the data.
I haven't seen any. I've just done it myself, so I haven't seen any other notebooks that do it.
Yeah, because I think that is definitely a worthwhile thing to do. Because especially as you go through 3 months, your first and second, your first month data that you get, if you don't use it to predict the next, then you're really, I think you can still kind of get away with it and, do okay, but you will definitely not be doing well in the competition. You don't do that, I think.
Well, that's what I thought as well. Yeah, like basically there's 3 months more data coming in. So if you're training models,
right,
you've got like a load more data. They're hopefully going to predict better.
Yeah, no, absolutely. Not even hopefully, absolutely will predict better, because this is the other thing, right? Is what I was saying earlier in Beckle alluded to in the answer to Mero, is the fact that that data in fact provides key value about the kind of the average level of the market too, if you think about it. Because it's, for example, just hypothetically, if your market was completely down in the 3 months that you're training on, and then the market is booming on the 3 months that you're predicting, you're stuck. But as the new data comes in, your model will learn to predict better. So it's almost a must. Without it, you're kind of stuck in the past. With it is how you would kind of adjust the overall level. It's kind of learning the correlations aspect and learning the levels aspect that Rachel talked about.
The other interesting thing with that is the other feature Steve was adding, right? The revealed target, which basically is a signal of how the current market is doing. So it's giving you what yesterday's input was and how to kind of adjust your prediction based on that. So yeah, like I haven't tried this, but one experiment I wanted to try was you just keep adding more and more and more in data, and then obviously there is a tapering point, right, when you kind of have no returns, or at least your returns become very minimal. Maybe that's a good time period to use on when to retrain your model. Something on those lines is what I was thinking.
The tip, or at least I have to think through this, I might be garbling the advice, but I thought one thing that they mentioned, and which is the reason that it kind of ties to what I also answered earlier when to your question, Rachel, is as you increase the data, your prediction gets better, because the way, or what I've seen in some discussions is that use at least as much data as you're expecting to predict.
Okay.
So if you're predicting for 3 months, you should at least have 3 months of data in your model, right?
Okay.
At least. That's something I've seen many people say, that if you're predicting for 3 months and you're using 1 month of prior data, your model is going to be hopelessly lost. You should probably at least have 3 months of data to predict 3 months ahead.
Right. So we are sitting with like what, 480 days or something, right? So that's like over a year. And so yeah, I'm just wondering if we can flush some old data. I don't know. I need to do this experiment.
Correct. No, that's exactly what Steve is doing in a way, right? Because he's limiting the max size. I don't know that it's precise, but he's doing that by limiting the max size, thereby flushing some of the old data as the new data comes in. And there it becomes a trade-off, as Steve also alluded to, between doing that and sticking within. I mean, one of the reasons you could do that is just because you want to use new data and purge old data. But the other reason to do it is also you have to stay within the time limits of your
competition.
So that's another forcing function to make you get rid of old data, which helps, but it doesn't unilaterally help, right? Like, because more data would always be better. So, but there's this balancing act of how much data, and there the other factor that comes in is the time that your model would need to run for. So you would be needing to limit it anyway.
Right.
Steve mentioned some number. I forget what he mentioned, but he was kind of limiting it by the total amount of data, I guess, that he's using.
Yeah, so like each date ID has 11,000 rows in it. So yeah, I'm limiting it to 600 days, I think. So yeah, 600 times 11,000 rows. I actually tried expanding it, and it didn't give me any improvement.
At some point,
and it was obviously going to slow things down. What I was wondering about was, like I retrain completely brand new models every sort of 10 days worth. You can fine tune LGBM models. There's articles about how to take an already trained model and fine tune it on new data, but I don't know. I don't know how well that works or whatever, because that's one thing I was wondering, like taking one of the trained models already and for every new row that comes in, fine tune it as opposed to retraining from scratch.
So one thing that the video mentioned, and I'm glad you brought that subject up, Steve. The video that I watched about the time series guys, that he was asked this precise question. So what do you do? Do you retrain or do you like fine tune? And one thing he said, and I have been needing to dig into that, is he said that LGBM, and exactly to your point, it's not like LGBM models. I mean, they don't have this fine tuning concept, unlike a ResNet vision model or a language model or something. But what he did say is that LGBM models have what he called, I forget the term he used, but out of memory ability to train. By that he meant, those are my words, those are not his words, he used better words. But bottom line, what I believe he meant was, if the data is too large, then LGBM allows you to train a model by bringing in new data. Okay? And his thought that same technique could be used to fine-tune a model as well. You see what he was pointing towards, but I haven't looked at it. That was something I jotted down to follow up on. He was saying LGBM definitely has the capability, if the data is too large, to bring in new data into memory and train. And he was saying, if you have that, then why can't that same technique or approach be modified to fine-tune?
Interesting. Okay, so like streaming data to be kind of updated on your model. So yeah, makes sense. I actually ruled that out completely, thinking it cannot be done.
That's an interesting pointer, but that's just a pointer. I mean, it's not like I haven't seen any blog post or any method or anybody showing me how to bring in new data if you're out of memory for an LGBM model. But that pointer, I think, is worthwhile, Steve, to give you ideas of what you're trying to do, fine-tune.
Yeah, I saw a notebook on Kaggle that was talking about it. It wasn't for this competition, it was for a different one, but I hadn't got around to checking it out yet.
Because that exactly ties to, and I jotted it down, it's towards the end of that video, but I thought, wow, that's interesting, because that's the only first time I've heard of fine-tuning an LGBM, but the way he proposed to do it was he was confident that LGBM allowed you to handle the case where your memory is not sufficient for the data. And if that's the case and you can bring in new data, then he said that method or the fact that LGBM allows you to do that is probably a good indication that you could potentially use that same technique to fine-tune an LGBM model. I wanted to chase that because that would be a good thing to have in the pocket.
And to give a quick update on what I was looking at, and there's a couple of interesting links that I found. Let me quickly share my screen. Never mind, let me just share the link directly because I need to give permissions and I don't have permission right now. So this one is, no, not because of that, I think. So my laptop, I haven't given access to Chrome yet. So that's a Neptune AI blog. So I was curious on how to pick parameters for an LGM model. No, because I had no head or tail on where to start with. I was just looking off other notebooks and trying to get things out. And this one gave me a I don't know, mix of both, like certain things work, just go with those things. And these are the certain parameters you need to care about to prevent overfitting and those kind of things. So I think it's a good article to read. There's a small segment in between there which talks about number of leaves and talks about how this is like a leaf-wise growth versus a level-wise growth of XGBoost. So something we were discussing on how the difference between XGBoost and LGBM, and this in fact kind of yields to faster training times of LGBM versus XGBoost, but inherently comes with the fault of you can end up overfitting very easily. Subsampling, feature fraction, those kind of things. If you're familiar with random forests, you've kind of seen what those do. A point which you brought up, a histogram, a way of doing things which makes it faster, that also kind of shows in max bins. And so there's a bunch of interesting stuff there, I think, to kind of read through and see that link. They allude to another link which I have seen before, but never really dared copy it or bothered copying it. Unfortunately, that one currently says that the app has been deactivated, but these guys, this Lore++, they do a lot of comparison between XGBoost and LightGBM, and they give you a bunch of default parameters to start off with. If you can't access that page, which I can't right now, they have a GitHub link, which is good. At least shows some of the other stuff as to what basic parameters or what not default parameters, but what parameters to start with and then kind of tweak. Then what was there's one more thing. Oh yeah, and then Steve, you mentioned you used Optuna, if I'm not wrong, right, for parameter tuning?
Yeah, I've tried to use it a few times, and yeah, like it gave me good results in sort of the cross validation. I got good things, but then when I actually tried to use those models on the public leaderboard, they weren't too good.
Okay.
So I'm not sure, did it just find parameters that overfitted?
Okay. And how easy was it like to use Optuna? Like from the code I was looking, it was like pretty much an import and then setting up a dictionary of your search space. Is that the same thing what you were kind of trying to do? Or
yeah, no, that's pretty much identical. Yeah, sort of can't remember. Does it randomly choose parameters and sort of works its way towards the best ones or whatever? But yeah, so it was easy enough to set up, but it just takes a long time to run.
Right. Okay, that makes sense. Cool. So I found one more which did that with Optuna and Bayesian optimization, just posting those links too. So I was going to try those out. What else? Then I had a few questions actually. So I kind of cleaned out my whole notebook because things were just not working with the idea you suggested, Steve. So I started with just the 17 features, added the lag feature of 1 day, and then kind of made a submission. And then finally, I understood how the submission API works. Succeeded with the submission. But yeah, my score was almost pretty much the same. So at least I have reached that stage with your idea now. What I wanted to ask you was, you are merging, when you do a merge, you do like day 1 stock 0 of the previous day gets merged with the new row that comes in, right? And,
is this to get the revealed target? Sorry.
Yeah, to get the revealed targets.
Yeah, so like in the API loop, you can like merge the revealed target data set that they give you. So there's a test data set they give you and the revealed target data set they give you. They've got the same time ID and the same seconds in bucket and the same stock ID. So yeah, I merge on those 3 things, which then sticks the revealed targets into the test.
Makes sense. So what I was curious, like I was thinking of this, wanted to see what you thought too. So if you look at how this buckets in second, that's the most granular running number that we have, right? So that starts from 0 and ends like at 540, if I'm not wrong. When you do this, so basically what I'm trying to say is that 0 ends at 540 and the next day would start and it would start at 0 and then end at 540 and so on. So now when you do the merge, you're merging the 0th second in the bucket to previous day's 0th second in the bucket. I'm wondering if adding another feature like adding the 540th second in the bucket of the previous day, because like in the time series, like that is the most, what is that called? The most past, if that makes sense, like the previous 10th second data, right?
Right.
Does my question make sense? It's like, do you think adding that, or is there something like inherently wrong with that idea itself?
Are you still just talking about adding in the reveal target?
So you add the reveal target, and that is basically the way you're doing it is you're looking at 540 rows before, right? In that sense, like if you're looking at the same for the same stock ID, for the same bucket and for the same date ID.
Yeah.
So I'm saying instead of using, rather, adding another column which would use instead of the 0th second, which is like pretty far back in time compared to the 540th second for that stock, right?
Right.
And so am I making sense, or am I maybe give me 1 second. Let me try joining on Slack from here. I can share my screen then. Can you hear me?
Yes.
Okay, perfect.
Oh, you are very echoey.
Yeah, drop them. That got it. Perfect. Let me see if I can share my screen.
Nikhil, can you hear us?
Yeah. Can you hear me?
Okay. So yes. So my question was going to be if is what you're suggesting or saying based on the premise that the 540th second of the prior day is closer to the 0th second of the next day than the 0th second of the prior day. Is that what you're basically trying to incorporate, or that your argument is based on that premise?
Yeah, exactly.
All right, yeah, I'm with you now.
Yeah. So I was just wondering, like, that is there value in like adding that and then so on and so forth, the 530th, and then it goes on like that, right? Like, is there some reason you think that wouldn't work, or is it like worth giving a shot?
Yeah, it's maybe worth having a shot at that. Yeah, so I add the reveal targets in, and then I stick it through. Do you know the guy's function where he generates other properties from it? So I end up with other bits from the reveal targets.
What function is that? Sorry, I don't remember.
It's like, yeah, if I just can you see my screen? Sorry.
No, not yet.
I'm not sure will it be able to. Yeah, like I'm probably the same situation as you, Raquel. Yeah, I'm through my browser or whatever. My Zoom had stopped working, told me to update, so perhaps I can't.
Yeah, it started screen sharing, but we are not seeing anything on your.
Can you see anything now?
Yes, we can see the. Yes, we can see.
Yeah, we can start seeing.
Yeah, now we can
see your side panel. Yeah.
Got it.
Yeah. So, where is it? Yeah. So, like, here's the API loop. Where is it? Oh, that's maybe the wrong notebook. So many notebooks. Oh yeah, so like there's like the loop, so you get like the test and you get the reveal targets. Yeah, so to join them together, I do this. Yeah, so I just as I said, like the other week, yeah, so the reveal targets, they're only valid every 55 steps. That's when they give them to you. So yeah, so like every 55, I take a copy of them, and then for each iteration of the loop, yeah, so I join here. So I join them on the date, the stock, and the seconds and bucket. So like, but then, so like now you've got the test data for like that one time step, and then it goes through this generate all features, which is the guy's function.
Okay.
The guy's function where he does like all that stuff or whatever, all of this. Yeah, so I added reveal targets in here, so I end up with sort of other features from reveal targets. I get about 6 or 7 extra columns based on the reveal targets with whatever he's doing here, like sort of shifting and returning and stuff. But yeah, like certainly you could do that. You could try making the reveal target, as you say, from the previous bucket as opposed to the previous day's bucket.
Okay. So this is basically doing a shift in person. Yeah. Okay. In essence. Okay. The same thing. Okay. Cool. Good to know.
Yep.
Same. And then there's a group by 21. What is that magic number 21 that you're using?
Oh, I think it's like because was it 21? Yeah, like that's, I didn't make that up. That's just come out of the blokes, the main, his notebook. Yeah, like
the tail 21. Sorry, tail 21. You're using like the last 21 after the group. I just could not understand what that piece was doing.
Yeah.
Do you have
I can't remember why. Yeah, like
cool.
as I say, it's come out of the main notebook.
Right. Yeah. I just don't understand what that was doing there.
Oh, I think it's maybe because of the fact that, so like effectively he's sort of caching and grouping the values 21 into the past. Is it from the 21 previous buckets? Is it?
Oh, okay. I know there's a minus where he does like the cache keeps getting appended, right? But but you want to make the prediction on only the last, whatever, that 11,000 rows. So that's where he does that minus length of test. So that indexing I understood, but this group and followed by a tail of 21, I didn't understand what 21 was. But anyway, I think probably need to print out some more stuff and look at what is going on there.
Yeah, I can't remember. Sorry, I had sort of thought about it before, but yeah, like I think it's maybe like the lag he's using, but yeah, it'd be worth printing it out to confirm that.
So, what else? Oh yeah, the extra column that we guys were talking about that we needed to drop, that is added only in the test, right?
Yes, it is. Yeah. Okay. And it only seems to have appeared this week.
Right. Okay.
Yeah, because they changed the API, and in fact, as I said, I'll post the link where they discuss that. But there's a couple of notebooks showing the change in the stuff.
So nothing changed for me other than just dropping that column and everything else seemed to work. Is that true for other? Okay.
Basically, if you look at the change that the guy makes, right? So what happens is only it doesn't matter when you're training and stuff. That's why what like he adds this. So he just says drop if this flag, the currently scored, is what is added, and if that's false, don't just skip over that part.
Oh, okay.
So he just continues, and then everything else. So then he drops the currently scored column.
Okay.
Columns equals
okay.
Scored.
Yeah.
So the reason why this is a little bit more, this piece of code fixes it, but it's kind of annoying because if you look at the thing, and then there's the discussion where they discuss why, and here this is where the guy says, okay, I'm changing, and interim hidden data set update is live. So if you see this post, as I understood it, and I haven't again dived into the details, I just wanted to get my code working again, but it seems that what he does is he skips, and the currently scored goes to false, or it's false for a while, then it's true for what you need to predict, and then it's false again the third time or the second time it's false is where actually, sadly, there is future data that they could potentially be using right now to give us feedback, but they don't.
Okay.
So a model runs against it, but they're not giving the score.
I see.
It's pretty annoying.
Okay. Actually, that again reminds me that I don't know if we spoke about this, but so our current test data is basically the copy of our ending of our train data without the target, right?
That's right. It's the last 3 days.
Last 3 days. And so are we doing anything different in terms of training? Are we chopping off those last 3 days when we are training, or is it just part of the training? Or I think in Steve, your case, you were saying you were using a split, right, which was way past, I don't know, some 400 days or something that you were saying.
Yeah, it was, yeah.
Okay.
But,
okay.
But yeah.
I think the notebook, which I think at least previously had the highest score, he has a true or false condition set up, basically, where if you're doing inference locally, then he splits his train. But the if condition basically uses the whole training to develop new models and then infer on that. So maybe that's why I was wondering, maybe that's why I'm getting like better local scores compared to like a public score. So maybe I think I need to make a change there.
Hey, anyone else chime in on what they were able to do? Mike, Emily, Terence?
Yeah, I was listening to you guys. This is my first non-deep learning. So I'm going through the right LGM and hyperparameters there. So I'm getting closer to what you guys are discussing. I also got through the book and understood the CV. What was the combinatorial purged clause validation? I got through the book. And yeah, the algorithm is pretty nice. The backtesting algorithm. And yeah, I'm currently trying to transfer that to code and get through the basics.
What do you, Emily?
I haven't really had much time to work on this lately. I was starting to try and build something from scratch, but yeah, just haven't really had much time.
Okay. What do you, Terence?
I'm still just going through various notebooks and trying to understand the principles. Haven't deviated from that yet.
Yeah, no, the series of videos lectures that for both you, Mike, and in Mike and Emily as well. If you haven't done time series, the link I'll post. That thing really is very good and a very rapid and good introduction to all of the approaches in time series, except deep learning based one, but that you can pick up. And later, there aren't that many anyway.
Oh, by the way, the second Kaggle notebook that I posted, which was the LGB plus parameter tuning, that is using Bayesian optimization. That's from that same Conrad guy.
Okay. Yeah, he seems to be a time series kind of
yeah.
expert in time series oriented stuff. Hey, anybody else? If not, by the way, let me know, guys, in Slack whether to do next week or to skip, given it's Thanksgiving in the US. I'm okay either way. So if people are going to take time off, then probably skip, but just.
I don't do Thanksgiving, so I'll be here.
I'm not in town, so yeah, I don't think I'll be able to make it. But yeah, I'll catch up with the recording if you guys are going to have one.
Sounds good. See you all next week as of now.
Okay, cheers. Have a good
Thanks
week.
everyone. Bye.
See you
Yeah,
next
thank
week.
you.
Bye.
Take care, everyone. Bye.